Okay, I'm going to make a quick video about using technology to calculate a confidence interval for a single proportion. So you can calculate your confidence interval by hand, but sometimes that can get kind of confusing as there's a lot of steps. So instead, you can actually use your TI-84 calculator to find the confidence interval in a quick way. To do that, you're going to press Stat. It's right below the delete button. You're going to go to Tests. And you're going to see a bunch of two-sample z-test, two-sample t-test, but we're calculating a confidence interval. So I'm going to scroll all the way down to one prop z interval, which is letter A. So A. From there, you are going to enter in your successes. So X is the number of successes. N is the total attempts. And then your confidence interval will be 0.95, so whatever percent it is as a proportion or as a decimal. And you'll press calculate. What that calculation is going to tell me is my confidence interval first, and it's also going to tell me my p-hat, which is my single value estimate within my confidence interval. So let's look at some examples. 2009-2010 regular season, Alex Ovechkin of the Washington Capitals had 50 goals. That's his number of successes in 368 attempts. So that's his N. So we know the X value for all of these is going to be 50. The N value is going to be 368. And we're going to calculate a 92% confidence. So if the confidence interval is not one of our exact 95s, 99.7, 68s, usually you're going to have to use a calculator as it's going to be faster than finding something called that critical value in front. And we're not going to go too far into that critical value. So for your confidence interval, for your C level in your calculator, you're going to type in 0.92. And once I type in that 0.92, and I press my enter, press my calculate, it's going to spit out that confidence interval. So it tells me my confidence interval is 0.1046 to 0.167. And I know what you're probably saying now, that was way easier than calculating it by hand. So let's find it for when the C level is 0.85. So same process. So stat, down to test, down to that letter A of one prop Z interval. And this time it's going to say 0.85 for my confidence level. And I just cleared it on my calculator. So just give me a quick second. All right, so when I press calculate, it gave me that 0.11016 to 0.16158. And we really only probably need to round to 3 decimal places. That's kind of going to be my rule of thumb. 3 decimal places. All right, and then I'm going to calculate the same thing for 50% confidence level. Okay, and when I do that, it gives me that my 0.1238. I'm going to go to 3, so it's 124 and 0.148. So what do you guys notice each time as our confidence level goes up? So as our confidence level is going up, is going down, my range of values is getting a lot smaller. So my interval decreases as confidence level decreases. And that's because I might be getting closer and closer and closer to what I think is the actual value, but I'm not really confident on that single value estimate. All right, let's look at another example. So the Opinion Research Corporation surveyed 1,008 adult Americans on December 17th through the 19th by telephone. When asked, do you approve or disapprove of the way Barack Obama is handling the job as president, 48% said approve. That 48% is going to be my p-hat. Okay, so if I have, my p-hat is composed of my successes over my n. So if it's 48% and my n is 1,008, I really need that x value in order to use the calculator. So I'm going to multiply 1,008 times 0.48, and that's going to give me the number of successes. So that gave me 483.84. Okay, so my x value is going to be 483.84. My n is going to be 1008. My C level this time, for my 98% confidence level, is going to be 0.98. I'm just going to plug that in my calculator. I go to stat, go to tests, go all the way down to letter A. So 483.84 out of 1008 for 0.98 confidence level. So it's going to be pretty wide confidence interval. And what's going to happen is it's going to tell me that I have a domain error. And the reason that it's giving me a domain error is because that decimal for the x value. So instead, I'm just going to say 483. 483, because we're talking about people. So 483, and that's going to give me a fairly close enough confidence level to where I feel like I'm actually getting that value that I'm hoping for with 48% accuracy. So 0.516. Okay, and it says to interpret. So we are 95% confident that the interval of plausible values from 0.443 to 0.516 contains the true approval, that's my context, proportion, okay. Is it possible that the actual approval rate was 0.52? So when we're asking about a specific value, we want to know if that value falls within that interval. So a lot of times when we're talking about a difference of proportion or difference of two means, we're looking for that 0. But here I'm saying, is it possible that the actual approval rating could be 0.52 instead of the 0.48? And based on our confidence interval, we would say no, because 52% is not within the confidence interval. So to make that decision, confidence. To make that decision, you're looking to see if that value is located. If we were asking instead, is it possible the actual approval rate was maybe 50%, I could say yes, because 50% was actually in the interval.